Hello, we're going here to talk about 1.5 complex numbers. First, let me give you the introduction for complex numbers. For example, a is a real number, and if you have a plus bi, together this is called a complex number. A plus bi is called a complex number, where a is the real part. In complex number you have two parts, real part and the imaginary part. So the real part will be just the numbers that you used to know before this, which is any number, and the imaginary part will be followed by I, and together they would give you a complex number. Okay, what's the idea of an imaginary number? This I represents root of -1. In real numbers we used to say that if you have a negative under the root, then there is no solution. And now in complex numbers I'll tell you that root of -1 will be I, an imaginary number. Let's say, for example, if you have root of -4, the answer here will be 2i, because root of -4 means 4 multiplied by -1. This 4 will go out as 2, and you'll be left here with the -1, which will give you 2i. So now let's see how to operate complex numbers. We'll start with addition and subtraction of complex numbers. First, the sum of complex numbers. Before this, we're supposed to talk about equality. Sorry, let me tell you something about the equality first. Okay. Equality of complex numbers. Okay, let's talk about equality of complex numbers. For example, if you have two complex numbers, the first one, let's call it z1 equals to a plus bi, and the second complex number, z2 equals to c plus di. So if z1 equals to z2, that means if these two complex numbers are equal, then it will be under one condition, if and only if a equals to c and b equals to d. That means if and only if the real numbers are equal and the imaginary numbers are equal. So only under that condition two complex numbers are going to be equal. Okay, now let's go to the operation with complex numbers. First we'll talk about addition and subtraction of complex numbers. Let's talk about the sum first. If you have a plus bi plus c plus di, then add the real parts together, a and c will give you the real part, and add the imaginary numbers, it will give you this imaginary part. This is an I, alright, this is an I. Okay, we'll have an example on this. And if you have difference between two complex numbers, a plus bi minus c plus di, then subtract the real part together, plus again subtract the imaginary part. Okay, let's have an example here. Okay, let's start with these two questions. Let's say that you have the first one, 4 plus 7i plus 1 minus 6i. Here work on the real parts only. 4 plus 1 plus, and now here the imaginary part, which is 7 minus, of course plus minus will be minus, so 7 plus minus 6, this will give you 7 minus 6 I. So 4 plus 1 will give you 5, and 7 minus 6 will give you 1i. It's a positive 1i. Okay, let's look at this second question. This second question is saying subtract. So first here for the real part, and here this will be for the imaginary part. Of course you're going to subtract here, don't forget that. 1 minus 4, the real part, and the imaginary part 2 minus 2. So 1 minus 4 will give you negative 3, 2 minus 2 will give you 0i. So this will be only a real part, the imaginary part will be 0. So the answer will be just negative 3. Okay, we have two more examples here. The first one is saying 3i minus 2 plus 3i. So this is an imaginary number that will be only operated with this imaginary number. So the negative minus 2 will be positive 2 if I'm talking about the real part first. And here 3 minus 3 will give you 0i, and the final answer will be just 2. It's a real part again. Third question, it's saying 3 plus 2i plus 4 minus I minus 7 plus I. Okay, first work on the real parts here, and here you'll have the imaginary parts. So the real part will be 3 plus 4 minus 7, and here for the imaginary part 2 minus 1, because the coefficient of I here negative 1, minus 1 again, because the coefficient of I is here again 1. So 3 plus 4 will give you 7 here. 7 minus 7 will give you 0, plus 2 minus 1 is 1. 1 minus 1 will give you again 0. So the final answer will be just 0. Okay, this will be our final answer. Now let's talk about multiplying complex numbers. First I'll give you the formula. Let's say that you're going to multiply these two complex numbers together. Okay, let's say that you'll multiply a plus bi multiplied by c plus di. So here you'll open the brackets, you'll do this kind of multiplication opening the bracket. So a times c, ac, a times di plus adi here, plus b times ci plus b times d, and you have two i's, so it will be I squared. Okay, here don't forget that we said the value of I is negative 1 under the root. So what would be the value of I squared here? If you square both sides here, if you square both sides, this will be cancelled. So I squared equals to what? Negative 1. So the value of this I squared will give you negative 1. So instead of writing this positive, like bd times negative 1 will give you here negative bd, right? Because bd multiplied by negative 1 is negative bd, and this positive will be just taken out. So now you can collect the real part alone and the imaginary part alone again. What's the real part here? AC and negative BD, plus, how about the imaginary part? You have AD plus BC This is our imaginary part. Okay, so this will be the formula for the product of complex numbers. Let's have some examples now. Okay, here I gave you two examples. Let's try to solve them together. The first one is saying 4 multiplied by minus 2 plus 3i. Just here distribute. 4 times negative 2 will give you negative 8, and 4 times 3i will give you 12i. So it will be minus 8 plus 12i. Okay, the second question. This one you have to open the bracket. So first 2 times 4, 8, 2 times 3, 2 times 3i will give you 6i, I times 4, 4i, I times 3i will give you 3i squared. Again here, don't forget what does it mean I squared. We said that I squared equal I squared means negative 1. So 3 times negative 1 will give you here negative 3. So this 3 will be changed to negative. So 8 plus 6i plus 4i minus 3. Good. Now collect the real part alone and the imaginary part alone here. So here you'll have 8 minus 3, and in the imaginary part you'll have 6 plus 4i. So 8 minus 3 will give you 5 plus 10i. So that will be our final answer. Okay, here I'll give you some questions that I want you to try by yourself, please. Okay, here I give you 5 questions that I want you to solve or to evaluate. The first one is saying 2 plus 3i plus 5 minus I. Second one, 3 minus 2i minus 4 minus 7i. Third one, 2 plus I minus 3 plus 4i plus 1 plus I. Fourth one, 2 plus I multiplied by 3 minus 5i. Fifth one, 4 minus 3i times 2 plus 7i.